Good morning, Pamedit. This is a video presentation by our group consisting of me, Sekar, and Dafnis. Our research project is titled Is Indonesia Decoupling? Evidence on Fossil Dependence and the Insignificance of Renewable Mitigation. Green economic growth refers to economic development that aims to reduce greenhouse gas emission while maintaining sustainable growth, with renewable energy playing a key role in decoupling growth from environmental degradation. In Indonesia, fossil fuel consumption remains dominant, far exceeding renewable energy use. While several studies show that renewable can reduce emissions, others find that rapid economic growth and structural inefficiency often offset this benefit. This inconsistency highlights a clear research gap. So this study examines the relationship between fossil fuel consumption, renewable energy use, gross domestic product or GDP, and carbon emissions in Indonesia. Literature review, economic growth, and environmental quality. The relationship between economic growth and environmental degradation is commonly explained by the environmental Kuznets curve, which suggests an inverted U-shaped pattern in the early stage of development. Emissions rise due to rapid industrialization, but as the economy matures, cleaner technologies are adopted and environmental pressures declines. Recent ERDL-based studies in E7 countries show that economic growth can eventually reduce carbon dioxide emissions once renewable energy reaches a critical level. However, evidence from Indonesia remains mixed, with several studies indicating that emissions continue to rise or follow a U-shaped pattern, suggesting that the country has not yet reached the EKC turning point. So the hypothesis 1 is economic growth, GDP, has a significant positive impact on CO2 emission, implying that the EKC hypothesis this is not yet valid in the context of Indonesia. Next one is fossil fuel consumption and carbon emission. Fossil fuel dominance persists due to carbon lock-in, a condition where existing infrastructure and institutional arrangement reinforce continued reliance on carbon-intensive energy. This creates a structural dependency, as firms remain tied to long-lived assets such as power plants and heavy industrial facilities, making a rapid transition to renewable difficult despite their technological viability. In Indonesia, empirical evidence confirms that fossil energy consumption remains a major driver of national carbon dioxide emissions. Together, infrastructural inertia and the inherent emission intensity of fossil fuels indicate that they will continue to be the primary source of pollution within the current energy system. So the hypothesis number 2 is fossil fuel consumption has a significant positive impact on CO2 emission, serving as the primary driver of environmental degradation in Indonesia. Next one is renewable energy adoption and emission mitigation. Renewable energy mitigates emission through the substitution effect, where clean energy replaces fossil fuels and lowers carbon intensity. This process is strengthened by the technological progress, supportive policies, and fiscal instruments such as carbon pricing. Empirical studies generally confirm that the higher renewable energy use reduces long-term CO2 emission, including evidence from Indonesia showing emission reduction in both the short and long run. However, in developing economies, structural constraint and industrial dependence often weaken this effect, meaning renewables still function more as a complement than a full substitute for fossil fuels. So the hypothesis number 3 is renewable energy consumption has a significant negative impact on CO2 emission, validating its role as mitigation instrument in Indonesia energy transition. Next one is model methods in data. This is the data we using for this study. We choose 4 variables. This is the CO2, GDP, fossil, and renewable. And this study utilized annual time series data for Indonesia from 1970 to 2024. And the model specification. This study employs the auto-regressive distributed lag ERDL bounds testing approach proposed by Pesaran. And this ERDL model estimation following the stationary check, the estimation process begins by determining the optimal lag order for each variable using the AIC. And the equation you can be seen on the screen. And next one, this is our research framework. We begin within the selection of variables. And next one is data collection, descriptive statistic. And next one is stationary analysis with ERDL bound test and then the model estimation. Next one is diagnostic and stability inspection, and then conclusion and policy implication, and finish with the limitation and future research direction. This is the empirical results and analysis. We begin with descriptive statistic. So you can see on the screen, these 4 variables have the mean, median, minimum, maximum, standard deviation, skewness, and kurtosis. The next one is the test stationarity with EDF and PP test. We're using URCA libraries to get those number, and this result indicate that the variable are integrated of mixed order, thereby satisfying the necessary condition for applying the ERDL bounds testing approach. The next one is the code if you want to generate the table level first difference before. And next one is ERDL co-integration test. So to verify the existence of a long-run equilibrium relationship among the variable, this study employed the ERDL bound test. And we also choosing the best model ERDL automated by the code. And this equation is the model, the best model that the code choosing. This is specification of case 2, restricted and constant, with R squared 0.9983. And we also compute the if F statistic, which is 4.8975 with p-value 0.00609. And this empirical evidence confirms the existence of a robust and stable long-run relationship between those four variables in Indonesia. Next one is ERDL result. We see that the ECT is significant at the 1% level with minus 0.425, confirming a stable long-run co-integration relationship. And this magnitude of the ECT implying a moderate to fast speed of adjustment toward the long-run equilibrium. And for fossil fuel consumption, we see this variable is highly significant effect in both the long run and the short run. This result provides an empirical support for the carbon lock-in hypothesis. And next one is variable of renewable energy consumption. This shows no statistically significant impact. And the economic growth, or GDP, displays a positive but statistically insignificant coefficient. And the results suggest that carbon emission in Indonesia are primarily governed by the carbon intensity of energy use rather than by aggregate economic output. The next one is model diagnostic and stability test. We choosing this of 4 stability tests with the Bruce-Godfrey serial correlation (LM) test, suggesting that the residual are free from serial correlation. The Jarku-Bera test confirms the normality of the residuals, and the Bruce-Pagan-Godfrey indicating the presence of heteroscedasticity. The Ramsey reset test suggesting potential functional from misspecification. However, when we see the model diagnostic and stability test with the recursive CUSUM and all LS-based CUSUM, these plots remain strictly within the critical bounds at the 5% significance level. Regression coefficient and residual variance remain stable throughout the entire sample period, validating the model reliability for long-term policy inference.
So, to continue Sekar's presentation, we come to the discussion section. So, for the long-run dynamics and model stability, we have valid long-run relationship, that is, RDL bonds test confirm a stable equilibrium among carbon dioxide, GDP, and energy use. And for the speed of adjustment, which is represented by ECT or error correction term, we have negative 0.425 that is significant at 1%, and for the interpretation, it is approximately 42.5% of short-run disequilibrium is corrected within 1 year. And the system exhibits a moderate to fast recovery speed, indicating strong resilience against external shock. And for the second part of discussion, we confirm that fossil fuel dominance as the driver in this research, which we confirm the carbon lock-in hypothesis. This implies emissions are structurally tethered to fossil-dependent infrastructure. Any increase in usage translates immediately to environmental degradation. And for renewable energy area, we validate the infant stage hypothesis, which renewable act as a minor complement, not a substitute. Current capacity is below the threshold required to mitigate emission effectively. For the last part, for the economic growth, growth doesn't derive emissions when fossil use is controlled based on our finding, which is which means pollution is governed by the carbon intensity of energy, not by the aggregate size of the economy or the GDP. So, to conclude our research, we find that fossil fuel consumption remains the single dominant driver of CO2 emission in Indonesia. And the structural dependence on dirty energy is robust with no evidence of decoupling over the 1970 to 2024. The infant stage of renewable has failed to reach a critical threshold, which means renewable energy is still not as effective to cover the energy dependence of Indonesia in fossil fuel. And for the growth versus intensity, economic growth is not the primary culprit. The carbon intensity of the energy supply is. So we can still have the desired economic growth, but it doesn't This implies that Indonesia doesn't need to sacrifice growth to lower emission, but must fundamentally alter its energy metrics. And for the implication, the first one is urgent need for carbon pricing. And the second one is the big push investment strategy. And the third one is the coupling strategy. So that's all from us. Thank you for your attention. See you.